I welcome you to my YouTube channel. In this video, I am going to teach you to calculate the mass of Ag deposited at cathode when the current of 2 ampere was passed through the solution of Ag in water. Here I have given a picture. In this one, let me consider the electrolyte used here is AgNO2. The electrodes which we used here of both are Ag. Clear? So now what is going to happen? When you apply current of 2 ampere current, if you apply for 15 minutes, they are asking you how much of Ag would deposit on this cathode. So when you apply current, what is going to happen to this electrolyte? So the electrolyte you have taken is AgNO3. This AgNO3 is going to undergo dissociation to give Ag plus and NO3 minus. Here you have Ag plus ion, as well as you have NO3 ions will be there, right? So now what is going to happen? This positive charge species is going toward cathode and there it gets deposited. This negative charge species moving toward anode and gets deposited. This is what actually happening here. Now they are asking you how much amount of Ag will be deposited when 2 ampere current is passed for 15 minutes. Let's now see. First, we have to write the given data. What are the data given here? Here, I value given. The current you apply is given, which is 2 ampere. And the current you are passing for 15 minutes. Now we have to first convert the minutes into second. For this conversion, I have to multiply it by 60 so that I will be getting 900 second. I am passing 2 ampere current for 900 second. Now, what they are asking me to find out? They are asking me to find out what is the amount of Ag would be deposited, right? So, first thing what I have to find out? I have to find out the quantity of electricity. So for this, I am going to use the formula Q is equal to I into T. The data I know it. So I value given to be 2 and the time I have to enter here in second, which is 900. If I multiply it, I will be getting the quantity of electricity as 1800 to. This is the first step you should know. The next step, write the reaction for deposition of Ag. Reaction for deposition. Here, Ag plus, when it receives one electron, it gets converted, it deposited as Ag. For this conversion, I have to first find out how many number of moles of electron required. I need 1 mole of electrons to deposit 1 mole of Ag. This is the concept we need to know. In 1 mole, I have 96,500 coulomb of charge, which is nothing but 1 Faraday of electron I require to deposit 108 gram of Ag. Because 1 mole of Ag, molar mass is 108. So simply I'm going to apply this. Here 96,500 coulomb of electricity will require to deposit 108 gram of silver. Then we are supplying only 1800 coulomb of electricity. So now what we need to find out If 96,500 coulomb of electricity deposits 108 gram of Ag, then 1800 coulomb of electricity would deposit how much gram of Ag? So let me just write here. So 1800 coulomb of electricity will deposit how much gram of Ag? For this, what I'm going to do, I'm going to write 108 here, and then what is the electricity I'm using? 1800 and divided by 96,500. So if I simplify it, I will be getting 2.014 gram of weight. So what is the conclusion we have got it? When we supply current of 2 ampere for 15 minutes, that would deposit 2.014 gram of weight. So let us now discuss the second question. In this question, when the steady current of 2 ampere was passed through two electrolytic cells. So let us now depict the diagram here. I have two cells. One cell, let me name it as A, and the second cell, let me name it as B. Okay, so here in the first compartment, I have taken zinc sulfate. In this compartment, zinc sulfate is taken. The second compartment, copper sulfate is taken. So here, zinc rod is taken. Here, copper rod is taken. Now this is the wire which connects these two rods. This is the wire which connects these two rods. Then here I have a batch. Here I have zinc rod bit, zinc rod bit. Here I have copper rod. Here I have copper rod. I'm passing current of strength 2 ampere. Here the current of 2 ampere is passed. At this cell B, I can find 2 gram of copper deposited. So the amount of copper deposited here is 2 gram. What is the first question? They're asking how long will the current flow. So to have this 2 gram of copper deposited at cell B, how much time 2 ampere current to be passed? This is the first question. To answer this, I'm going to use Faraday's first law. W is equal to Z I into T. So Z is electrochemical equivalent. How can I find this one? The formula is equivalent weight divided by Faraday. This is nothing but Z into I into T. So this will give you how much is the weight. So in this question, the weight of copper is given, which is nothing but 2 gram. You have to find out how long did the current flow. They are asking you to find out what is the time taken for this. So what I'm now going to do, I'm going to just rearrange this equation. So how I'm going to do it, I'm going to bring this term and I have here 2. I'm going to bring the Faraday term to the other side. So I'm going to get 96,500 divided by the equivalent weight of copper is 31.75, and the number of Faradays used in this process is 2. How am I saying that it is 2? So here copper plus 2 you have, Copper plus 2 has to receive 2 electrons to be deposited as copper. So the number of moles of electron involved here is 2. So I'm writing 2 here. So if I'm simplifying this, I will be getting 3047. Now let us move on to the next part of this question. What mass of zinc would be deposited at the cell A when 2 gram of copper is deposited at it? So they are asking you here how much amount of zinc would be deposited. To answer this, I'm going to use Faraday's second law. This law says W1 divided by W2 is equal to equivalent mass of one substance divided by equivalent mass of other substance. Here, let me consider 1 to be zinc. So I'm going to rewrite this. Mass of zinc deposited divided by mass of copper deposited should be equal to equivalent weight of zinc divided by equivalent weight of copper. What is the question? I have to find out what is the mass of zinc. So let me write for mass W, mass of zinc I'm going to find out. And I know that mass of copper is given in the question is 2 grams. So let me write 2 over here. And the equivalent weight of zinc is 32.5 gram divided by equivalent mass of copper is 31.75. Since we need to find out W mass of zinc, I'm going to bring this term to the other side. W zinc is equal to 32.5 into 2 divided by 31.75. If I simplify it, I'll be getting 2.047. This is my answer. I hope you understood. Thank you for watching.